Hi guys, Sinan this side, and in this video we are going to discuss how to differentiate e to the power x using the first principles. So what does first principle actually say? It says that differentiation of a function f is equal to finding the limit, this limit h tends to 0, f of x plus h minus f of x over h, right? So in our case what we wanted to find is d by dx of e to the power x. So what this actually gives is limit h tends to 0, e to the power x plus h minus e to the power x over h. Fine. And if you know the laws of exponents, you can rewrite this as limit h tends to 0, e to the power x times e to the power h minus e to the power x over h, which gives us limit h tends to 0, and if you take out e to the power x common, you get this e to the power h minus 1 over h. Now what you need to observe is that this e to the power x is independent of h, so we can actually take this outside the limit. So what this gives us is e to the power x limit h tends to 0, e to the power h minus 1 over h. Yeah, and if you remember your limit course properly, you would know that this limit is equal to 1. So what this gives us is the value of this is e to the power x times 1, which is e to the power x. Yeah, we are done, but let me slightly go over why this limit is 1. Okay, so the question was limit h tends to 0, e to the power h minus 1 over h, right? So what we'll do is write the expansion of e. So that is e to the power x is equal to summation I equal to 0 to infinity x to the power I over I factorial. Fine. So what this gives us is limit h goes to 0, and I can write e to the power h as 1 plus h square over 2 factorial dot 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 infinite terms, and in the end I would get a minus 1 over h, and this is equal to, and before that we can just cancel out these two ones. So what remains is limit h goes to 0, h plus h square over 2 factorial plus h cube over 3 factorial dot 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 over h. Now if you observe, each and every term of this expansion or this infinite series is actually having at least one h. So what we can do is factor that out. What this gives us is equal to limit h goes to 0, h over h times 1 plus h over 2 factorial plus h square over 3 factorial dot dot dot, and using limits, you know, you can cancel these two h. So this gives us limit h goes to 0 and 1 plus h over 2 factorial plus h square over 3 factorial and dot dot. Now if you observe properly, this is not an indeterminate form. Basically you can put the value of h in this expression without having any problem. What this gives us is this is equal to 1 plus 0 plus 0 and infinite terms of 0, but summation of all zeros is still 0, so this value is 1. So finally you could now say d over dx of e to the power x is equal to e to the power x. We solved this using the first principle, and additionally we showed that limit h tends to 0, e to the power h minus 1 over h is actually 1. Yeah. So we are done. Thanks for watching. Bye.